All right. Hey, everyone. Welcome to the provider IBM Cloud meeting today on July 29th. My name is Sadhu Zala, your meeting host today. Just code of conduct before we start. I just started recording. Please keep in mind that this meeting is a public meeting, so be nice to each other. And the meeting is being recorded and it will be made available on YouTube Kubernetes channel. I have shared the agenda in the chat, and if you take a look at the agenda, add your name there, please, if you can, or I'll add it later. But we have a few things to the agenda. We have Kuan here as a guest speaker. We're talking about hybrid application model around managing applications across various providers, platforms. So we have a couple of folks who needs to drop earlier. So I have put the talk at the top of the agenda. Yeah, we'll go with that. So without any delay, Kuan, thank you so much again for being here and, as a guest speaker and to give this talk. So I will hand it over to you. You can share your screen now. And if you can introduce yourself as well, that would be great, Kuan.
Okay, thank you. Thank you for having me here. Let me start with sharing. Okay, just okay. So this is Kwan. I'm going to talk about the hybrid architecture model. So maybe a little bit about myself. So actually, I joined IBM after the graduation, and then still there. And I was working on the IBM Multi-Cloud Manager, I think, in the last 3 years. To the Edison world. So I was really focusing on the application lifecycle management in that product. And until recently, we started to expand that application lifecycle management from originally a container focus to a hybrid model, in which case we want to cover the application across containers, virtual machines, cloud service, etc. So for that, we created a community called Hybrid IPP-IO, and then that's what I'm going to talk about today. Okay, then so this is the outline of the content of today. So I will start with the overview and then talk about the core resources and tools, and followed by a quick demo with the CLIs. Okay, so let me start with the overview part. So like I mentioned earlier, the motivation for us to do that is to actually help the user to manage application across various platforms, including containers, virtual machines, cloud services, etc. And also because even for the same platform, let's say for the container, there could be multiple providers. Like we know that we have the Red Hat Advanced Container Management, and we have other things like the kubefed and the Rancher. They all provide similar capability. So this model is intended to help the user to also navigate across different providers for the same platforms. So the approach we are doing is because we believe that the container or Kubernetes itself will be the trend, and then we are kind of trying to focus on that platform. So we are building this model as the custom resource extension to the Kubernetes API server. So being said that, for those non-Kubernetes assets, like for example, the virtual machines, I mean, for the OpenStack or other tools, so those assets need to be surfaced to Kubernetes APIs somehow. So I'll mention that later. So we built this model with the open architecture in mind, so that we can actually integrate with various deployers coming later to the party. And also we make this interface open so that we can actually serve the developers and DevOps and also AIOps, so that they can all leverage the model to do whatever they want. So the model itself is actually focusing on the deployment perspective of the application components, but because we actually manage the lifecycle of those components, so it can also facilitate other tools like the monitoring and logging to help them to find what is the application and how to be more focused under the application umbrella. So this is the overview. And then as we showed in this chart, so we actually have two big categories of the functionality here. The first one is the core resource. That's the part how we actually build the application model. And then we have another category of the tools actually help users to better use this model in their daily life. Okay. So moving forward, so let me start with the core resource then. So the core resource actually consists of following parts. So the first one is the application resource. Of course, since we want to manage the application, we need to define the application. And then we have all those artifacts defined with us. We have the deployable and the subscription and channel to help define them. The difference here is if you want to define a resource right inside the Kubernetes cluster, we use the deployable to do that. And if the artifact itself is somewhere else, like for example, it sits in the GitHub repository or it's in the Helm repository, we define the channel to point to that actual repository and then use the subscription to filter that package from a specific repository. So with deployable and the channel subscription, we can actually model those artifacts user want to include in the application. And then after these things are deployed, we introduce the placement through customer resource to help user to define where they want to deploy those resources. And last but not least, in order to embrace all different kind of deployer, like I mentioned in the beginning, those container-oriented deployers and virtual machine-oriented deployers or cloud service or other stuff like Edge. So we introduced this deployer resource to describe them. So I'll briefly go to the details for each of them just to give you a better understanding of that so that you can better enjoy the demo later. So for the application, so application itself, we actually adopted the SIG application definition so that we can actually interact with other tools already developed in the community as well. So the key things we want to highlight for the SIG application is actually the selector and of the component kinds. If you are familiar with that, if you're familiar with the Kubernetes, actually, you can find that this is the way the application to group things. So in brief, the application is trying to group certain kinds of the resources with specific label. So these are the kind of the essential of the application itself. And then what it is grouping, and like I mentioned earlier, we are grouping deployables and also channel subscriptions. So in the deployable resource, we are trying to define it as a way to aggregate different kind of possibilities across different providers or deployers. So in the deployable resource, we have the hybrid templates defined so that user can actually incorporate different type, within the same resource. In other words, if a developer, if he wants to deploy, let's say, a database for his application, so that database could be deployed as a deployment, or actually a stateful set maybe, in Kubernetes. And then it could also be a virtual machine deployed by KubeVirt, or it could be something else like a virtual machine deployed by ManagerIQ or other stuff there. Or it could be provisioned by a cloud service. So with that, with the same deployable resource, the developer can actually be more focused on the logic of the component itself and separate the actual details of the deployment. Okay, so and also one thing to mention is inside the deployable, we use the spec placement to specify which placement rule it will use, and then we can deploy it to the right places. Then, so sitting side by side with the deployable, that's the channel and the subscription resource we have. So the channel, like I mentioned, it is something to define a place. For example, a GitHub repository, or an object store, or a Helm repository, or another Kubernetes cluster. So that place serves as a artifact store. Artifact store, sorry. So that we can actually store things there. And this could be other CI/CD expansions there to define criteria to gate or auto-promote things among those channels. Then after the channel is defined, user can define their subscription resource to actually point to a channel to subscribe packages. And because there could be actually a lot of packages inside a repository, like for example, if you check the public Helm repository, there are tons of the packages there. So in the subscription, we let the user to define the criteria to filter the package in the channel. Let's say he or she can actually subscribe a Helm chart with this specific version or something else. Okay, so that's what we have in the subscription and channel that helps you to define a resource for his application outside the Kubernetes itself. Then moving forward, that's the placement rule. So today we actually are using the placement rule from the Red Hat Advanced Content Manager, but we actually are trying to improve that. It's actually a work in progress right now. So in the new placement rule, we still have the basic way for user to select the target by the labels. because we say target here because it's not necessary to be a cluster in Kubernetes. The target could be a virtual machine. The target could be a cloud service provider. That's why we say target here. But those targets are actually modeled in this hybrid model as a deployer. And then with the very basic feature, we can select targets by the labels. And then we also introduced the advisor mechanism for the user to better select the details. Like for example, we can have, so here we have two types of the advisors. When it's similar to the Kubernetes scheduler. So we have the predicates and the priority advisors. Predicates means that they have the veto power, and the priority just help to sort things. So the example here, like for example, we look at this one. This is a alphabetical advisor. That means it will sort all the clusters alphabetically and then just pick the top one from them. And all the veto power, that means this one can actually veto out some clusters if they like. So with all these advisor mechanism is also open so that user can introduce their own advisors to help facilitate the placement. Like for example, if you want to sort things by performance, we can also do that here as well. So this is very brief about the placement rule. There are a lot of things to play with it, and also there are a lot of things to think about with the AI ops stuff to help you to pick the right one. Okay, then last but not least resource we introduced here is the deployer. So the deployer itself has a type to define what it is. So by default, it is Kubernetes because we are really focusing on that. And then the deploy itself could be defined as, with a scope of the cluster scope or the namespace scope. That's really means what is the jurisdiction of that deploy. In which case, if we want to deploy a virtual machine or a stuff for that virtual machine, do we want to put that into the same namespace, or it can actually take care of other resources all around the hub cluster? Then other stuff here, like the placement target, is actually trying to describe what is the target to be scheduled. That's exactly the thing will be decided by the placement rule. And also other capabilities is more like the role of that operator. So what is the actual resource this particular deploy is deploying? Like for example, if it's KubeVirt, then the resource here will be the KubeVirt virtual machines and the verbs are associated currently. So that's basically all the resources we have in this model. And then moving forward, let me talk about the tools here. So we know that all the users are really Kubernetes users. They are familiar with Kubernetes. And then it will take some time for the user to actually adopt something new. So the first tool we introduced in this hybrid model is the application assembler. So that means if user has some existing applications, and then they want to onboard that into the hybrid model, this tool can help them. So we can actually, there are actually two ways to do that. One way is to help to let user to compose a application assembler resource themselves to indicate what other components they want to have in the hub cluster or in the managed clusters. And then we can help to generate, sorry, we can help to generate hybrid deployables, placement rules for them. Another way is to leverage the application itself to discover the resource from the managed clusters. And then we continue to generate that for that. So this is exactly what I'm going to show in the demo to let you better understand how can we actually onboard a existing Kubernetes application into this hybrid action model and how to play with that. So that's the main tool I would like to introduce here. So then let's go to the actual demo piece. So before we start the actual stuff, I'm going to talk about the story here. So this is exactly what I mentioned earlier. So there is an application already running, and we want to include that or onboard that into the hybrid model. And after this onboarded, so we want to manage that across the different clusters. So this is, I think, a typical scenario. So people can start something with a simple, let's say, a Minikube, right, for their own applications. And then after they think it is ready, there should be an easy way to play with the hybrid model to help them to lift it to the model and then to distribute across different clusters and at a scale. So the thing I'm going to do is with following steps. And I should have mentioned that everything we did with the community is done with the CLIs. So that's why I want to highlight the steps here so that we can you can still follow me when I switch to the actual terminal. So the first step is we actually did that already. I deployed a guestbook that's a typical example from the Kubernetes resource. And then I will create application CR to help the discovery of the resources. And then I will show you how to just annotate that application CR to actually generate all the hybrid deployable resource we have. And then we play with the placement to see how can we actually lift that application and then distribute it among different clusters. So that's the demo I'm going to do. Okay, let's go to the actual stuff here. So here, this is the A cluster. I think I have that right here. So you can see that I deployed the guestbook here. The only thing I did on top of the traditional guestbook is I added the label. You can find that, where's my mouse? Okay. So you can find that I added the hybrid action model sample app equals guestbook, that label to those components so that it can facilitate the later discovery activity. Other things are just the very original guestbook from the community. And then you can see that we have all the pods running here in this cluster as well in this guestbook namespace. Okay, then let's switch to the model side. So this is the hub cluster. So if we look at that, is we have actually 3 clusters here. Yeah. So this one, I keep losing my mouse. So okay. So this one actually deployed to in the Toronto cluster. So what I'm going to do is I'm going to apply the application resource to do the discovery. So just to show you what I'm going to do is, so this is the application resource I'm going to apply. So you can see that we added the annotation for the user to actually do the discovery. So I'm going to apply that. And after that, you can see that this application is created. And if we look at the applications, you can see that it is just generated. And if you look at the details, you can see that in the status, it's actually discovered all the resources from the managed cluster. And then let me make a little bit modification there to the model to actually enable this create assembler annotation so that we can actually generate other resources. So as of now, you can see that we only have the application resource. We don't have anything like the hybrid deployable or placement rule here in this namespace. Okay, sorry. We only have the application resource here. But after I apply this modified annotated application, sorry, then it will help us to generate all the resources required. If I get the same stuff here, you can find that now we have all the hybrid deployables generated in the last couple of seconds. And also we have placement rule also generated. So until now, there's nothing changed or nothing happened at the management side. So this cluster is still running with all the deployments or services there in the managed cluster. And then after it is generated here, we can further play with the placement rule to manipulate it. Like for example, we want to move it out of the original cluster. So we can just add the placement rule because originally the cluster, the assets is deployed into the Toronto cluster. If we just change that to the Raleigh cluster, and then you can find that after it is modified, then you can find that the placement tool is actually generate new additions. It is the status of that is went to Raleigh now. And then if we go back to the managed cluster, we can find that this thing is gone. So yes, put us in the terminating status because it takes some time, and it will eventually come from there. And then if we that one is actually into the Raleigh cluster to be deployed. So you can see that everything will be created into the Raleigh cluster from the hub point of view. And then we can also, of course, we can further do that. Let's say we want this thing to be deployed to more than just one clusters. We can edit our placement rule here to just give more clusters in the names. Let's say here that I want it back to Toronto, and then it has 2 clusters listed there. So we can, if we switch to that original Toronto cluster, you can find that all the pods are coming back. So the original 3 things are terminating, but it will be back soon. And we can find that the deployments are also generated here. So that's what we have with the hybrid action model to manage all the resources here in the hub cluster and help user to play with multiple clusters. So with that, they can easily start something simple with one cluster and then eventually upgrade it or move it outside the cluster and go to other clusters. Yeah, so that's basically what I want to demo. And then just to summarize what we just talked. So we have the hybrid abstraction model showed. We talked about the core resources, and we talk about the tools to help the onboarding. And also the last but not least, that's the two links we have for the hybrid abstraction model. So the first one is the community of this hybrid abstraction model. That's where we are. And also the other one is the RACM, Red Hat Open Cluster Management. That's the Red Hat Advanced Container Management. That's another important community we have to facilitate the application lifecycle. Okay, that's all from me. Any questions?
That's pretty cool. I'm definitely it sounds like I thought you were actually using KubeVirt, right? Did I read that right?
In this demo, not, but it could be leveraged.
Yeah. Okay, yeah, because I was doing some stuff in KubeVirt, and I thought it'd be really awesome to be able to, because its strength was being able to bring the virtual machine as well as the container inside the cube to make what I call the cube stack, right? So there's sort of a hybrid of that. So I like that idea. So let me ask you this. It feels like what you're doing feels like a how you call it, a Terraform like product or AWS CloudFormation product. Is that kind of the sort of the concept that you're shooting for Kubernetes being the platform to deploy things?
It's not exactly Terraform, but because we are actually defining things in Kubernetes as the CRDs. But I think the idea is kind of to go to that level to be general and unified. Yeah.
Okay, yeah, I like that. Just to give, like, I don't know if this is released yet, just to be able to explain to the user base, sort of conceptually what you're trying to do. It sounds like you made use of CRDs so that you could specify like an entire architecture. And I could see templates of these, collections of these CRDs and stuff that we can put in a library somewhere so that we can create reference architectures for various customers to be able to use that are compliant, with various standards and stuff.
Yeah, that's right. Yeah. The only thing I was hesitating is I don't want to confuse people by that to let them understand that we are using Terraform. It's not we're using the customer resources in the Kubernetes. Mm-hmm. Yeah. Other than that, I think it's good.
Yeah, that's very nice. Thanks.
Thank you.
So who is I mean, obviously this is a public channel. So how far along is this in terms of getting it in the customer's hands for IBM customers?
So yeah, for IBM customers, we have a product called IBM Cloud Private. Oh, sorry, we have a product of IBM Multi-Cloud Manager or IBM Cloud Platform Management. So that's the actual product having this.
Oh, great!
So I think
it's already there. Okay.
Yeah, it's already there.
Oh, very good.
That was great. So, Kuan, any other questions, anyone?
But one more thing, can you post that? You showed the GitHub link. Could you post that in the chat here?
I mean these things?
It was something apps.io.
Yeah, this one. Okay, I can put that into the chat.
There you go, hybridapp.io -io. Okay.
Yeah. I already put it on the agenda doc as well under notes.
Oh, very good. Thank you.
Yeah, just for reference.
Okay.
Yeah. Cool. So other quick question, Kuan, I know you showed in the IBM Cloud, but I guess you mentioned that this can be leveraged across providers cloud. Is that?
Yes. Okay. Yes. So currently we did the integration with the Red Hat container management, but I think the model itself is open. As long as the user want, they can do whatever they want. Like for example, Kubernetes is another case if they want to do that. And then we also do other integration, like for the Manager IQ. That's also with the original Red Hat asset. But nothing stops user from doing more than IBM or Red Hat assets as well.
Okay, that's great. That's great. Awesome. Well, thank you so much again, Kuan. This was great. Learned something new, and we have those links and other reference materials. Mike, I see one of the link you put on the MCM app side, so I'm going to put that in agenda as well for reference.
Okay.
No other questions, Kuan. I think we can continue with our agendas. You can stay or drop if you want, but I think we should wrap it up soon. So if you want to stay.
I did have one question. Are you using UBI as the base, or some other repo? Do
Sorry,
know?
you mean using UBI for the as the
Yeah.
as the base of the image? Yes, we are using UBI.
Yeah. Okay. I was just curious where it would be applicable to run it.
Okay.
Cool. Thanks.
Yeah. Awesome. Well, thanks again. So going forward, we moved the introduction for new members. So Kuan, you already did that. So thanks again. And I just wanted to update everybody, that we have recorded a couple talks. So Richard and myself, we recorded a talk just to updating, what's going on, right? And about the project and the GitHub repos and other things about IBM Cloud Provider for the virtual China conference. So it's Cloud Native China. So we have submitted that one. And then Khalid and myself, we created one more for virtual KubeCon Europe. We're supposed to travel at that time, but with all this, virtual conferences going in now, we ended up, they requested, they still there, the Europe one, it's supposed to be the end of the March, I think, but they're doing it late, so it will be next month. But they wanted the recordings, so we provided them the recordings. Anything else? I mean, it's open discussions. Richard, do you have any updates? Anything you want to cover from cloud provider?
No.
Or anything?
No updates for me today. Thanks.
Okay, great. Thanks. I guess that's pretty much it. I mean, so we didn't have much in the agenda. So unless Mike or Dennis, you have anything to discuss, we can call this
Nope,
meeting.
I'm good. Thanks for asking.
The demo was interesting. Thanks for
Yeah,
sharing.
definitely. Yeah, thanks for doing that, Cole.
Yep, awesome. Well, then let's just wrap it up. We had a good 30-minute call. So see you, everybody. There are some, I think, questions on the Slack channel. I'll be looking at it, but somebody's interested in the GitHub repo we have for the cluster API. So if you are interested, take a look there as well. But other than that, thank you so much, everyone, again, and see you in the meeting next month.
All right, thanks a lot, guys.
All right.
Thank you. Bye.
Take care. Bye. Thanks, Kieran, again. Bye.
Bye.